Hello, good morning everyone, and welcome again to our online science class. Today is Sunday, it's the first day of the week. How was your weekend? Did you have a great time? That is awesome. So today we're going to have an exciting topic. So to start with, kindly get your pen and notes. We're going to need it for note taking. So remember some important concepts in here and get your course book for your reference. Are you ready? Well, if you're ready, I'm going to give you here first some mind-boggling pictures that you need to take a look and answer these questions. Alright, so here's question number 1. Look carefully in this and which event where this light is usually used. Time is up. Where do you think? It's of course an Olympic torch, so it's used in Olympics. Next question. Look carefully at this. And what kind of light is used in here? Let's see if you get it correctly. I think you're really familiar with this. It's the UV light or the ultraviolet. Next question. What device is this? And we'll look at the picture and how it looks like. Let's see if you get it correctly. It's simply an infrared sensor or just an infrared. Did you get it correctly? That is awesome. Next question. What device takes or has the ability to take this image? You are well aware of this image right over here, and you have seen it 1,000 times. It's in the airport and it's the X-ray. Next question. Look carefully at the video in here and try to identify which event is happening in here. Let's see. It's called Aurora Borealis, and it's found usually on countries near North Pole or in the North Pole itself. So, how much did you get it so far? Please let me know in the comment section below. Please write your mark, and hopefully that you get a perfect mark on this. And if you get a perfect mark, that means you're really well aware and very knowledgeable about this trivia. So, what do you think is our topic for today? Since we're talking here about colors and colorful things, our topic for today is all about the spectrum of white light, but we're going to take a look also with the bending of light and try to review with that. We had a previous video about the bending of light, and we're going to incorporate that kind of lesson in this lesson, and we're also going to take a look here about the dispersion of the white light. So if you have your course book, you can open it on pages 154 to 158, and we're going to take a look with the following objectives. We're going to take a look here with how the light bends, and we're also going to analyze the spectrum of the white light when light is being split. So here's the first question. I know that you're really familiar with this one. How do we see a rainbow? So how do you think we see a rainbow? So if you look there, it needs to have a rain, that is right, or a water droplet to see a rainbow. But usually in the laboratory, we can produce a rainbow by just using a certain kind of material, and we call that the prism. So you can see the colors of the rainbow for yourself by seeing a ray of white light, and I want you to take note of that word, bending into a glass prism. So we're going to take a look here. How do we produce a very colorful rays of light just using the sunlight, or just a ray of white light? So before we go into that, I just want you to take a look with this one. So I have here a beaker, and I have there an oil, and which is mixed with water, and of course the oil is less dense, so it goes higher up, and the water just sinks there in the beaker, and I put oil on the test tube. So if you notice, when I put the test tube on the beaker there, the middle part of the beaker disappears. Why do you think is that? So that will also answer the question by just looking at this one. There's a coin at the bottom of the glass, and we put the glass, and then we pour the water, and suddenly the coin would disappear. So why do you think the coin disappeared? Well, last time we have talked that light strikes the coin, and this is why we can see everything here on Earth, because light strikes it and it reflects back the light. So the moment when it reflects the light travels from the coin to the glass and to the water, and of course the air. So it travels through the three media: glass, water, and air, and therefore all of these materials bends the light. So what happens here is that before it reaches your eyes, the light tends to bend here in a angle that we can't see anymore. So we call this kind of incident as refraction. So here is a good question. What is a refraction? So we're gonna test it here with a laser light just right over here. So we're gonna use red, and I have here blocks of glass. So if you look here, this light just passes through here. So again, light travels through a straight line. So what I'm going to do is I'm going to bend one a little bit. So look what happens to the light. Is it still straight? No, it's not yet. It's not straight. So let's try to use a different kind of material. So let's try to use this one. This one is a glass. So look. So does light travels in a straight line? Yes, it travels in a straight line. But when the light reaches this block of glass, what happens to it? It bends. So this phenomenon is called refraction. So based here on this experiment, you can now identify what is refraction. So what do you think is refraction? If you have your notes, kindly write there your thoughts. So let's compare it with what I have in here. So what is refraction? Refraction is just simply the bending of the light. So when the light reaches here, a different material, this one is the air. I have it here, the environment is in air, it is the air, and this one is a glass. So you have there two media, the air and then the glass. So when the light reaches a different media, it changes its direction. So the change of the direction of the light when it enters, or in this case, it leaves also a transparent material, the air and then the glass. So it bends, it changed material, it changed the direction when it reaches here, in here, and in here, and again it enters the glass here, it changes the direction. So we call this phenomenon as a refraction, and we're going to relate later why forming colors of the rainbow results from refraction. So they say that light travels in a straight line. However, why does it bend in here? Why the light tends to refract in this scenario? What are your thoughts? Again, the clue here is that the environment here is the air, and of course it's definitely transparent, and the glass here is also transparent. So why does the light bend? It doesn't travel, well, it travels in a straight line, but it bends upon reaching the glass here. Why? Well, first is light travels here in a different material. It's the air and in the glass, and light bends towards the normal when it passes through different materials. So let's try to see if I'm gonna make this one just water, look, it tends also to have to bend differently when it's in the water. And of course, this one is just a purely glass, so I'm gonna change it all to air. So try to see, so it bends. However, if it's just no other materials here, it's just purely the air, the light travels in the straight line. So if you want to bend the light, you need to let the light pass through a different material, in this case the glass. So refraction happens when light travels in a different material. On your everyday life, you can actually observe that. Well, like we have here the fish, but let's say a coin drops in a swimming pool and you thought that that's where you're gonna pick it up. But however, when you pick it up, it was not there. You need to move your hands a little bit higher, and this is actually what's happening with how we see fishes under the sea. So this is the actual image of the fish, but this is how we see it. So when the light reflects on our eyes, this is how the image would look like. So going back again a while ago to the experiment about the coin. So the angle of the incidence is here in the water, and it reaches here. The light reaches here with the fish, and the angle of refraction here tends to be different. Why? Because now the light would travel from the water and go into the air, and the water here has an index of n is equal to 1.33. The air has an index of 1. So try to see there's a difference between the index in here. So what will happen is there's a different angle now, okay, between the angle of incidence and the angle of reflection. So this one is the angle of incidence. Okay, it should supposed to here in the reflection, and the angle of reflection is different now. It's from this blue line that you can see in here. So for the refraction, before we take a look at that, for the reflection, light has an equal angle between the angle of incidence and the angle of reflection. That is the law of reflection. But for the law of refraction, the angle of incidence tends to have a different angle with the reflected ray. So what happens here is that the image that has been reflected, that we can perceive, that we can see, tends to be different from the actual image that is found in here. So let's try to put the fish right over here. Let's try to move the fish. Okay, or let's change the index here. It's 1.3. Okay, so the eyes here, the image that is reflected with the fish also here tends to be different depending on the position of where are we looking the fish. So if we're looking the fish just right at this angle, which is a smaller angle to the normal, the fish here tends to be deeper than where the actual fish is, and it has a bigger image. However, if we're going to decrease the index here, let's say we look at this angle, we increase the angle here from the normal. So what happens here is that the fish that we can see is thinner than the actual image, and it's at the top. So this speaks about the refraction. So why do we see the fish at a different angle or a different position than where the actual fish is actually from? It's because of the refraction. So let's connect now our topic with reflection that was last time and our topic now with the refraction, and let's try to differentiate refraction and reflection using the following categories that I have here. Number one, what happens to the light during refraction and reflection, and the angles formed of the incident ray and reflected ray. So if you have your notes with you, kindly put your answer on your notes, and we're going to compare your answer with what I have here. So I'm gonna give you a minute to think about the difference between reflection and refraction, and we're gonna try to see what you got. Alright, so your time starts now. So it's pretty fast. 1 minute is over. So can you see your answer? So let's compare your answer with what I have in here. So these are the difference between reflection and refraction based on how light travels. Of course, light travels in a straight line, but during a reflection, light bounces off on the from the surface of an object, like a mirror, and we have there two kinds of mirrors that I have shown to you, or any shiny object. Light tends to reflect from it. However, for the refraction, light do not bounce off. However, light here tends to bend. The bending of the light is called the refraction. So let's also compare reflection and refraction based on the angle which is formed. So it is known that in the law of reflection, the angle between the incident and reflected ray is equal, just like is what is shown in here. They are always equal no matter what. However, for the refraction, the angle formed between the incident ray, the one which I'm pointing right now, and the angle formed here between on the reflected ray, so this one is in normal, is not the same or is different. Why is that? Because the light here traveled in a different medium, two media. We have here the air and in this case the water. So if the light travels into two media, we have there the air and then the water, light will tend to bend, thus refraction occurs. So these are just a few difference between refraction and reflection. So since we're talking here about bending of light, I have this material in here. Okay, so this is a triangular glass that separates the colors of light when it bends. So this is just an example of glass material. So it has the ability to bend the light. So actually, when light bends, what happens in here is that, look at what's happening in this material. So when the light strikes the prism, by the way, this one is called prism. So what happens to the light? The light bends when it reaches the glass, and it's very obvious in here, and this is how it looks like into a graphic representation. So in this case, you have noticed that this one is color white, and after reaching or after bending inside the prism here, you can see several colors. So why do we see several colors in here? So the white light splits into a spectrum of colors. So what are the spectrum of colors? So if you take a look with this one, it's always in a certain kind of arrangement. Even this one, all of that, even the rainbow, while this one has the colors of rainbow in it, and all light under the spectrum, or when it splits, always have this arrangement. So we call that the Roy de Vive. It's red, orange, yellow, green, blue, indigo, and violet. This is how it would look like. So the one that you can see here is the different wavelengths. We call this a wavelengths because light travels also in waves. So this is the white light, and these are the different colors that has been separated from the white light. So if you notice, it starts always with red, followed by orange, yellow, green, blue, indigo, and lastly we have there the violet. So we call this as the colors of the spectrum. So I have here the words, and we need to match it with a perfect definition that we have here in A and B. So we have here number 1, spectrum, and we have here dispersion. So spectrum, what do you think here in the spectrum? Is it letter A or letter B? So let's see. Spectrum here is letter B. So this happens when the white light is separated or is being split up into different colors. So these different colors are basically the spectrum of the white light. And the dispersion is the phenomenon where the prism splits up the colors from the white light or from from the sunlight. So I just want you to remember these two terms that we have in here. We have spectrum and dispersion. Again, spectrum, these are just the colors of the light which result from splitting of the white light, usually using a prism. And the dispersion is the process by which we split the colors of the white light. Well, in this case, we use again a prism. So how does this dispersion takes place, and how do we produce the spectrum of light? So naturally in nature, when we don't have the prism, we have actually the rain or the droplets of water. So we're going to take a look here with the phenomenon naturally on how the spectrum of light is produced. So we have there rainbows in front of you, while at the back is your sun. So each of course, raindrop contains the water droplet, and let's pretend that that is a prism because it acts as a prism. So this triangular object here will be refracting those light, and every time it bends the light, it produces this spectrum of light. So it's always in Aurora Borealis. So these are the droplets, and this is how we see the colors. So each droplet here will be giving a color, and this color will enter the eye. So let's have this one. Okay, you can see the difference in the color that enters the light. Why each droplet tends to produce different colors as it reaches the eye? Well, that depends upon the angle where we can see that. So at this angle, we can see the red. At this angle, we can see the yellow. At this angle, we can see the violet. At this angle, we can see the blue. So this speaks upon that light produces a different color, or we can perceive the color that has been refracted or that has been dispersed from the light based on its angle. So since light here travels in a wavelength and the light bends from the prism, therefore we can differentiate this light based on its wavelength, or certain kind of colors are being produced depending on the bending of the light. So if you take a look here, which color is produced, or which color is produced when there will be more bending, or which color tends to bend more in here. So if you look here in the prism, it's the violet and blue bends more. So this one shows here the graph. This shows about the wavelength of the light and its corresponding energy. So the symbol NM in here speaks about the length of the wave. So here you can see that light travels in waves. So the length between one wave to the other, we call it the wavelength, is the length. So look here, this one is color red. It has a wavelength. This is the symbol for wavelength. It's the lambda. So it has a wavelength of 700 nanometers. And look at whether it bends more or not. Let's compare it with violet. This one is for the violet. It has a wavelength of 400 nanometers. So does it bend more or does it bend less? Well, definitely violet and blue tends to bend more. It has a nanometer of 400. That means that the wavelength is really short. However, if you go to red, the wavelength becomes 700 nanometers, so the wavelength becomes wider. It becomes longer. So this will also speak about the energy it is carrying. So again, the shorter the wavelength is, the more energy it has, and the longer the wavelength, the lesser is the energy. So the more bending there is, the more energy there is. That means it is a stronger, it carries a lot of energy, and the weaker, it has a longer wavelength, has also the longer wavelength in here. So which color has less energy? Well, definitely it's the red because it bends less. And the one which has more energy here is the violet and blue. So in real life, we are using a lot of these colors for our daily lives. So why most of the warning signals are red and not blue? So in airport, in airplanes, in cars, even in traffic, and even in a lot of warning signals in factories or in any kind of work, we are always using red. So why most of the warning signals are red and not blue? So it is because that red bends less, so it tends to have a longer wavelength, so it can travel farther. And also red can be seen from far distance. So while we can say that red can travel in a very far distance compared to blue, and why red is being used. So let's take a look again with this one. Red again has a 700 nanometers wavelength compared to blue, which is only 400. That means that red has a longer wavelength, so the light can travel farther compared to that of the blue. So if you want to use a warning signal that people can see even though they're really far, so use the red color instead of blue. So since we're talking here about colors, so there are these colors in here. I have your red, blue, and green, and these are definitely called as your primary colors. So your primary colors are red, green, and blue. So when two or more of these colors of light are mixed with each other, just like what's happening in here, we call this phenomenon as a color addition. So what will happen if I add all these primary colors? What color will it result to? So let's take a look. Look here at the middle where I combine all of this color. Oh, let's just take a look with this one. See? Okay, I combine all the colors in here, and of course it results to white light. Therefore, white light is not just colorless or not just white. It is formed because it's a combination of the different colors. So how do we see colors? So to answer the question, how do we see colors, let's take a look with this experiment right over here. So we are using here filters of primary colors. We have their red, blue, and green, but here we can use a variety of colors, not just the primary colors. So look here, again, light contains all the colors, so let's use the white light in here. So when we use the yellow filter, what color do we see? We only see the yellow. If you use the red filter, you can only see red. If you use the blue filter or the violet or the purple filter, we can only see violet. Or if you use the blue one, we can use blue. So why we can only see blue if we use this filter? Why is that so? So let's use this wave in here. So again, this light contains all the colors. I hope that this one is really visible to you. However, if you use the blue filter, look at what color can only pass through the person. And that's the color that we perceive. Exactly, it's blue. So why we only see blue? Well, the reason for that is all colors that we cannot see are the ones that are absorbed, and the colors which are transmitted, in here transmitted, or in the other hand, reflected, is the color that we see. So when we see blue filters, when we see colored blue, the blue filter here absorbs all the color except for the color blue, and that's why we see blue light. However, let's take a look with red. In here we have red. Look, all the colors are being absorbed, only the red passes through or being reflected, and that's the reason why the person here can perceive red color. And the same thing with green. So how do we see green color? Let's put it in the darker one. Okay, it's here. So the green color, all colors again is reflected or is absorbed. I mean, all colors are absorbed except for the color green. And this is the reason why we see only green. But sometimes we also perceive different colors. So we might perceive these different colors because of the combination of the different colors. So we have here red and this amount of green, and this amount of blue, and this is the color that we perceive. Now let's increase the red, and we see a pinkish one. So we see colors based upon the color which is definitely being transmitted or being reflected. If it reflects color blue, we see blue, and if it reflects color red, we see red. So all colors are just absorbed. The color which is being reflected or transmitted is the color that we see. So let's take a look here with the leaves. It's very green, and it's usually very relaxing to the eye. So why do you think the leaves of the trees or the plants is green? Exactly, because it absorbs all the color, however it reflects the color green, and that's why we see the leaves of the plants as green. So why do you think it absorbs all the color? Again, because all of this color tends to certain kind of wavelength has energy, so the light has energy, and the sun will be giving the energy to the leaves, so the leaves gather all of them, and it will only reflects green because it's the middle, so it contains the energy which is not really very beneficial for the leaves, so it will be getting higher amount of energy, which is they usually take it from blue or from violet. So today so far we have discussed about the refraction of light, the dispersion of light, and how do we see colors. So this time let's test how much you have learned so far. So please prepare your pen and notes with you to answer, and later on I'm gonna record your mark and let me know about your mark. So question number 1 and 2 here, write reflect or refract. So question number 1, is this a reflection or a refraction? Very good. This is just definitely reflection. Let's go to question number 2. Look at what's happening here. Is this a reflection or a refraction? So it is refraction. Let's take a look with question number 3. Name the material that I have in here. What do you call this material? Exactly, we call this your prism. Question number 4. We see the leaf as green or color green because it reflects what color? Exactly, it reflects the color green, and it absorbs all the color. And lastly, the splitting up of white light into separate color, just like the one in the rainbow. What do you call this process? This process is simply called dispersion. So how much mark did you get? Did you get all 5 correctly? Let me know in the comment section. If you have questions or clarification about this lesson, kindly revise it from the start. You can rewind it anytime, anywhere, in your most convenient time, or you can send me a message if you have any clarification. So that is all. You can now close this video, and see you on Tuesday. That will be all. Goodbye, everyone.